Okay, I'm going to do a recording of the lesson 4.6. I also have a webcam in the bottom right-hand corner. There'll be a few problems I'm going to do on it. Objectives are to show that pairs of angles or pairs of sides are congruent by identifying related triangles and proving them congruent, then applying CP/CTC. The launch is to construct two congruent right triangles. And then how do you know your triangles are congruent? And use a paragraph proof to justify that your triangles are congruent. Okay, so to do this, I'm going to use the SAS congruent shortcut. I'm going to start with a line segment on my paper. And it doesn't really matter how long it is. Just make it a certain length. Okay. And I'll just I'll label the endpoints AB. Now, the way I wanted to make it was I didn't want to make it so long that I can't duplicate it, right? So I'm going to measure the distance of it with my compass, and then I'll come over here and put a point. I'll call it point X, and come over to point X and swing an arc. And then I draw a line segment from point X until I hit the arc. I'll call that point Y. Okay, so then to make a right angle, I'm going to do a perpendicular bisector that's a little bit more than halfway in between. And so swing an arc from here, and swing an arc from point B, swing an arc from point X, and then an arc from point Y, right on point Y, there we go. And there we go. So this perpendicular bisector will construct a right angle. Both top and bottom. Line that up here, down here. Good. Okay, I'm going to call this point D, call this point Z, and let's see. Yep, and then these points meet at the same point as this one. And so I'll call that point C, and I'll call this point W. And look at that. So what I can do now is connect C to A and W to X. There we go. Now, perpendicular bisector means that AD is congruent to XY. And because C and W are where these meet, and these have the same compass settings, WZ is congruent to CD, right? So AD is congruent to XZ, and then CD is congruent to WZ, and also angle, we'll call it ADC, is congruent to angle XZW, which they're both 90-degree angles. And so by the side angle side conjecture, triangle ADC is congruent to triangle XZW. There you go. And so that is the construction. This is the simple, not a paragraph proof, but it is a basic proof. these are all true. This is all given. And then by the SAS conjecture, they're congruent to each other. Okay, that's the launch. The next slide. In lessons 4.4 and 4.5, you discovered 4 shortcuts for showing that 2 triangles are congruent. They are the SSS, SAS, ASA, and SAA. And the definition of congruent triangles states that if 2 triangles are congruent, so this is like the crux of this lesson right here. If 2 triangles are congruent, then the corresponding parts of these congruent triangles are congruent. This is called CPCTC for short. This will be used a lot in this lesson. And let's see how you can use congruent triangles and CPCTC. So we do a series of problems and proofs here. Okay, starting here. Is AD congruent to BC? So is this congruent to this? That's the question. Use a deductive argument to explain why they must be congruent. To show this, I need to show that triangle ADM is congruent to triangle BCM. Once I prove those triangles are congruent, then all the corresponding sides and all the corresponding angles are also congruent, meaning that AD at that point will be congruent to BC once I do that. So to show that's true, I need a congruent shortcut. Well, I have vertical angles at 1 and 2. Those are congruent to each other. So those are the same. And then I have a side that's the same and an angle. Angle A is congruent to angle B, right? So angle A is congruent to angle B. And then AM is congruent to MB. And angle 1 is congruent to angle 2. So because this is all true, and this is because of vertical angles, and these other 2 are given to us, then what's true? Well, this is true. Triangle ADM is congruent to triangle BCM. And this is because of angle, side, angle. Okay. So on the next page, they basically tell you that. So these steps are angle 1 is congruent to angle 2 because of vertical angles. It's given that this is true. By ASA, this is true. And because the triangles are congruent, AD is congruent to BC by CPCTC. So the last set of this proof would be AD is congruent to BC, and the reason is the corresponding parts of congruent triangles are congruent, meaning all the corresponding sides and all the corresponding angles are congruent. So that is a basic proof. This obviously isn't part of the proof, but what you see here is proof, called a 2-column proof, basically, where you have your statement, and then over here you have the reason. So angle A is congruent to angle B because it's given. So I can reason, right? So these are a series of reasons. All the green here, those are the reasons. And then the light green, these are the statements. Each one of these is a statement. And each of these statements has a reason. And that's the idea of a deductive argument or a proof. Cool. So again, if you use a congruent shortcut to show that 2 triangles are congruent, then you can use CPCTC to show that any of their corresponding parts are congruent. So we use the congruent shortcut, ASA, to show that the triangles are congruent. And then with CPCTC, we showed that their corresponding parts are congruent, basically. When you are trying to prove that triangles are congruent, it can be hard to keep track of what you know. Make sure to mark all the information on the figure. If the triangles are hard to see, you can use different colors to redraw them separately. That would be very helpful. For example, in this proof, as a group, you're going to discuss how to prove AE congruent to BD. In triangle ABC below on the right, when you are trying to prove that triangles are congruent, it can be hard to keep track of what you know. If the triangles are hard to see, you can use different colors to redraw them separately. For example, the triangles you can use to show congruence are triangle ABD and BAE. You can use separate or color. You can separate or color to see them more clearly. So the original figure that you're given is right here. What they did was, well, the red and the blue triangle will be easier to see if I draw them separately. So they did. And now I can clearly see, oh, look at that. These angles are congruent to each other. These angles are congruent to each other. But what else do I know? Well, if you look back at this figure here, do you see how this side is the bottom of both triangles? And so AB is clearly congruent to itself. So that can also get marked. So now I have three things that are marked. And they get into writing a proof. What would that proof be? Well, simply put, this is going to be side, angle, angle. And then I know that the triangles are congruent by side, angle, angle. Therefore, why would that be congruent, right? So if I show that, okay, so triangle ADB is congruent to triangle AEB, why is that? What shortcut? Well, SAA. Okay, so then AE is congruent to BD. Why? Because the corresponding parts of congruent triangles are congruent. Done. Okay. Now in the proof, there's a few more steps. In these triangles, these are congruent because why? They're given, right? So they're marked on the drawing. These are given. Okay. In addition, this is congruent, right? The bottom of the triangle is congruent because they are the same segment. So if you ever have something that's the same segment, it's implied to be congruent. Then this is true because of this reason, and then this is true because of that reason. So you basically have a proof here. And I'll go ahead and underline the statement in red. These are all statements. And then the reason in green, right? So the reason is given, the reason is same segment, the reason's SAA, the reason CPCTC. So if you were to make a 2-column format, the red would be your statement and the green would be your reason. Okay. Summarize. What 2 questions should you ask yourself to start proving triangle congruence? Well, there's 2 questions. The first is, which triangles do I want to prove congruent? And then, which triangles can I prove congruent from what I know? What are 2 things you can do when it's unclear which triangles contain the corresponding parts? You can label the pictures and draw auxiliary lines. Extra example. TV bisects STU. Okay, so these are congruent because that's an angle bisector. Okay. Is this true? Is angle S congruent to angle U? Well, let's see. So by this picture, angle STV will be congruent to angle VTU. Why? because of angle bisector. Angle bisector. And typically you say definition of angle bisector. We know that angle SVT is congruent to angle UVT because it's given, right? They're both 90-degree angles. Okay, so these angles are congruent to each other, and then these are congruent. Okay, but also look at this side right here, right? So TV is congruent to TV, same segment. And there you go. So it looks like the triangles are congruent. So triangle STV is congruent to triangle UTV because of angle side angle. So now I've shown the triangles are congruent. So the question is angle S congruent to angle U? It is. Why? Because the corresponding parts of congruent triangles are congruent. And that's what they explain right here, basically. So you have, this is true because TV is angle bisector, and then this is true by ASA, and this is true by CPCTC. Closing question. In the diagram, AB is congruent to ED, right? So AB is congruent to ED, CB is congruent to CE, and angle B is congruent to angle E. Are the triangles congruent? Well, it sure looks like they are. It looks like SAS, side angle side. But it says they're not congruent. Why not? The vertices must be in corresponding order. This is a little bit of a technicality, but if you look at this, it says that A, B, C, right? So if you look at this, you start at A, you go to A, B, C. Here it says D, and we should go this way, right? We should go from D to E, but we go D, C, E. So this is not true. However, if it were to say ABC, congruent to what? What triangle would be correct? Well, if you said D, E, C, then that would be true by SAS. But because the letters are in the wrong order, the angles don't correspond, it's not true. You'd say false. Vertices must be in corresponding order. This is super important. Okay, that concludes lesson 4.6. Thank you for listening.